Okay, we'll have a discussion here on these last few problems that you were working on in class. A 1,250 kilogram small aircraft decelerates along the runway from 36.6 meters per second to 6.8 meters per second, which is going to be our initial and final velocities. And it says in a time of 5.10 seconds. I know nothing about acceleration at this point. If I think about how to find my resistive force, which is going to be my force of friction I know is mass times acceleration. Well, I can use the given information here in order to determine acceleration. And once I have my acceleration value, I can substitute that in with my mass to get a force of friction or a resistive force of about 7,300 newtons. Number 56 talks about a tow truck exerts an 18,300 newton force. So that's going to be my applied force upon a 1,210 kilogram car, dragging it out of a mud puddle. We have a 17,900 newton force that opposes the car, so I could consider that my frictional force. And it says the car is going to be moving horizontal. Determine the time to drag the car a distance from its rest position. Initial velocity is 0. But the one thing that can relate distance, initial velocity, and time is going to be my acceleration, which I don't have. But I'm given enough information in my forces that I could find my acceleration. So I could find my net force by taking my applied plus my force of friction. So I get a net force of 400 newtons, and I know net force is equal to mass times acceleration. Substitute your net force, your mass. We can solve for acceleration. Then we can turn around and use that with the other given information about its motion to find the time. And we have a time of 6.5 seconds. '57. We have a 4.4 kilogram bucket suspended by a rope. So we have a rope, and accelerates upward from an initial rest position, which means initial velocity is 0. Tension in the rope is 83.1 newtons. Determine the speed after 1.59 seconds. So we're looking for velocity, final velocity. We have the time, and what variable is going to relate initial, final, and time. I'm going to need to find acceleration. So looking at my net force, I know my net force is going to be the tension force minus the force of gravity. So I can figure out my force of gravity by taking the mass of my bucket times negative 10 meters per second squared, which is acceleration due to gravity. And then I can use that to find my net force of 38.7 newtons. Well, that force is what is needed to accelerate my bucket. So that force will equal the mass of the bucket times the acceleration. And solving for that, I can get my acceleration to be 8.7 meters per second squared. I can use that information along with my initial velocity and my time in order to find my final velocity using this equation. And my final velocity should be 13.8 meters per second. The last example from class. Shopper in a supermarket pushes a loaded cart with a horizontal force of 16.5 newtons. So that's going to be my applied force. We have the mass of the cart. We're looking for how far in meters, displacement, will it move in this time interval, starting from rest, which means initial velocity is 0. And it says neglect resistive forces. So quite simply, my applied force is going to be my net force. So substituting 16.5 in for the applied, 33.8 in for the mass, I can find the acceleration of the cart being 0.5 meters per second squared. I can use that along with the other information in order to find distance. So my distance is equal to half the acceleration times time squared. Substitute my newfound acceleration. Don't forget to square the time, and we have a displacement or distance of 0.43 meters.